Hi everyone, this is Jill Hurston with CenterZip. I just want to welcome you to our webinar today. I'd like to introduce Mike Watson. He is CenterZip's VP of Engineering, who will be moderating today's webinar. Mike, over to you.
Thanks, Jill, and welcome everyone to today's webinar, Descaling with LeSS. Today we are going to talk about scaling up Scrum in order to achieve organizational descaling. At this point, I'd like to introduce our speaker for today, Craig Larman. He's the co-creator, along with Bas Vodde, of LeSS, Large-Scale Scrum, and since 2005 has worked with clients to apply the LeSS framework to descale development in big product groups. All right, Craig, over to you.
Folks, hi, my name is Craig, and I'm trying to reduce suffering in product development. And just before we get started, a quick promo. In Austin in March, I'm going to be doing two public courses. One is a 3-day course on organizational design and systems thinking with LeSS, and the second, another bailiwick of mine, is a computer science topic, which is advanced object design. Now, on to the main subject. I want to start off by sharing with you a brief story of how we got here today. So in September of the year 2000, I got an email from an old friend of mine and colleague, a guy named Bob Martin. And Bob invited myself and Kent Beck and Ken Schwaber, Jim Highsmith, and a group of folks back in the late 90s who were involved in the introduction of lightweight methods at the time. And Bob's motivation to call a meeting was that at the time, the appellation that was used for these approaches, XP, Scrum, adaptive software development, and so forth, was called lightweight methods, and nobody was really liking that name. And so Bob said in his email to us requesting that we get together for a meeting, he said, I want a name and I want some kind of a marketing manifesto. So it was agreed to finally get together in February 2001 in Snowbird, Utah. And then there was this activity to come up with name. Now, one of the people at the meeting and one of the progenitors of this movement, one of the founders of the Agile Alliance, was a guy named Jim Highsmith. And Jim Highsmith was the author of a book which was very seminal and influential at the time called Adaptive Software Development. And Jim's approach was called Adaptive Software Development. So not surprisingly that during this meeting in Snowbird, when the discussion of name was coming up, Jim suggested the name Adaptive. So that got on the list. Now, another person at the meeting was a guy named Mike Beadle. Mike had co-written the first book with Ken Schwaber about Scrum, and Mike had recently finished reading a book called Agile Competitors. And Mike kind of liked that name, and so the word Agile got on the list as well. And then there were a few other words that were chosen, and finally then there was voting. Now, as a small sub-part of the story, not everyone knows this part, many of the people at this meeting were self-employed consultants, and the feeling amongst some of them was, you know, if we vote for the word adaptive, then Jim's going to get all the business. And out of kind of the concern for Jim not getting all of the business, the word agile got a few more votes than the word adaptive. And then we got to where we are today. Now, I'm not just trying to share a kind of potted lexicon history here. There's a point that I want to make, is that you could easily be going to some conference or part of some special interest group called Adaptive 2020 instead of Agile 2020. And notice that alternative choice of word, adaptive. It's a synonym actually of another word that was on the voting list, which was flexible. And you'll notice that none of these words were synonyms of fast. The group that was voting was very clear that this was not about fast time to market. And you'll notice that none of these words are synonyms of productive, because the group was clear that this isn't about some kind of local efficiency. What the group was trying to share was the idea of having the humility to respond to change and learning, to take a kind of a scientific approach to product development with hypothesis and then experiment, collecting data, and then feedback in a loop, and then changing direction in directions that were previously unanticipated. That kind of changing direction rather than following a plan to a set of fixed functionality in a future date was the raison d'etre, the key motivation behind this approach. Now moving on, once we understand that the idea of these approaches was to be adaptive, it kind of then begs the question, well, what does adaptiveness mean? So if we're going to have essentially a loop-based system for development as opposed to a sequential approach to development, a traditional sequential model, which is plan-execute. If we're going to move from that plan-execute model to a loop-based model of scientific method, hypothesis, experiment, data, confirm, disconfirm, change direction, then we understood in the early days of this movement that there's a couple of preconditions, or more specifically two preconditions, that have to be in place for this kind of an approach to work. And these relate to adaptiveness. One of these is called in process theory the transaction cost of a process cycle. So what do we mean by that? So for example, suppose that for example, I started development back in the 1970s myself as a developer, and we used to do this thing called manual testing where humans actually interacted with computers. It was very wasteful, very inefficient, but we did it. So imagine that I added up the costs of manual testing back in the 70s, and every time for a delivery cycle, it was, let's say, translated into cost, $50,000 worth of manual testing cost. And then I go to the accountant of the company and I say, hey, accountant, every time we want to do a delivery cycle of software, we add $50,000 of transaction costs for the manual testing. And then I ask the accountant, how many loops should we do a year, 20 or 1? Well, you can well imagine that the accountant's going to want to say 1 because they want to reduce their transaction costs. And so one of the key insights of the early days of the adaptive Agile movement was we need to change the organizational design to drive down transaction costs as close to zero as possible. Otherwise, there's going to be a lot of friction in order to create a loop-based system. The second key force that's relevant is sometimes called the switching costs, or the switching the switching dynamics related to changing direction, which is not exactly the same thing as the transaction cost. So for example, imagine that you've got 700 people working on a particular set of goals, and then halfway through you discover that those goals become invalidated because of data or feedback, and then the group of 700 people has to change direction in a new unanticipated direction that hadn't been considered before. So rhetorical question, what are the costs that are going to be involved in changing direction? How long will it take? How much work in progress is there? Do people have to learn new things? And these are all related to the switching costs. And the key point I want to conclude this little section on is that if you want to quantify adaptiveness, what it really kind of boils down to is the question, are the transaction costs of your organizational design as close to zero as possible? And are your switching costs as close to zero as possible? Let's move on. So I want to now shift to another subject, which is the question of organizational design and system optimizing goals. As I sometimes introduce myself, my prime work is as an organizational design consultant. And what I'm going to be sharing isn't really new ideas. They're very well established for many years, which is the idea that in organizational design, you're trying to achieve the org design for some goal. You're trying to set it up so that it achieves some goal. And that then begs the question, what could some goals be of an organizational design? Let me write some down here. Well, one, as we've just kind of alluded to, is increasing adaptiveness. And now that we've looked at adaptiveness in terms of transaction costs and switching costs, an inverse way of saying that is reducing the transaction costs and reducing the switching costs. Another possible goal is, for example, lowering end-to-end cycle time from concept to cache. Notice that's not the same thing as adaptiveness. Moving on, another possible goal could be increasing ideation, the generation of ideas in the service of innovation. And we could go on with other goals as well. But before I go further, I want to make a suggestion to everyone who's listening, which is don't make a self-licking ice cream cone. Don't make a self-licking ice cream cone. What do I mean by that? In other words, we're not trying to create adaptiveness for its own sake, or low cycle time for its own sake, or ideation, or et cetera for its own sake. It's really in the service, ultimately, of what I call business objectives, such as increased market share, increased return on investment, et cetera, because bottom line, the company needs to stay in business. And so these, let me call them internal goals, are ultimately should be connected strategically to being in the service of some business objective. That's the second point that I want to make. Now, I want to move on to a case study. So there's different kinds of organizational design elements that exist in software-intensive product development. One common org design element are called component teams. Component teams is when you have groups of programmers associated with different chunks of code. For example, if you've got front-end programmers or back-end programmers, then you've got a set of programmers attached to a subset of the code in a different layer or a different module or a different application. And if you have that kind of a structure, you have what are called component teams traditionally. So if you've got a team around a particular microservice, you have a component team. If you've got a team around a particular layer or subsystem, you've got a component team. If you've got, as I mentioned, a database team or a front-end team, you have a component team. Well, so what? I want to do an analysis that connects this to the subject of adaptiveness, which I briefly introduced, and also to the subject of optimizing goals for an organizational design. Let's start off, though, with just an analysis of the implication of component teams. So if we have component teams, such as the front-end programmers, mid-tier programmers, back-end, maybe device driver programmers, a rhetorical question, who's going to do the user experience analysis and the business functional analysis of what's wanted? Will it be the back-end device driver teams? And why would the device driver programmers be doing the user experience analysis? It doesn't seem to make sense. So therefore, if one starts with the constraint of there will be component teams, it naturally leads to the following further role in an organization. Some kind of a role that we could just call analysts of some kind, user experience analysts, business analysts, and so forth. And before going further, I just want to pause and make sure we understand the basic point, that the apparent need for this role, and also they will certainly make some kind of an artifact as output, the apparent need for this role and this artifact and this process step is a side effect of having started with component teams. Given that constraint, it gives birth to the apparent need for this role. Moving on. Now, the next question to ask is what component teams are involved in a particular requirement? Let's give it a name like F1, looking at the story of F1 from beginning to end. Well, my world of development isn't typically 50 or 100 developers. For example, many of you know I worked on the LeSS adoption for the self-driving car at BMW, been involved in large-scale development of telecommunication systems and so forth. And in those worlds, there's typically 1,000, 2,000 developers on a single product. And so there's many components, and if they're organized into component teams, there's many component teams. And so then, key point, a question arises for the requirement F1, what component teams are going to be involved in working on it? Because it's not going to be all of them in this case. So somebody needs to answer the question, what component teams? Now, who's going to answer that question? Which component team is going to answer the question, which component teams? We have a kind of chicken and egg problem here. Another problem to resolve is that once the components are identified, like maybe C6, C9, C12, then the question becomes, who's going to be responsible for a cohesive internal architectural design that works effectively and skillfully across those different components? For example, would the back-end device driver team be responsible for identifying which components? Would the back-end device driver team be responsible for the end-to-end cohesive design? It doesn't seem to make sense because of these siloing of roles. And as a consequence, what's usually introduced then is the following. Another role called typically architects, or in my world that involves hardware and software, they're sometimes called systems engineers. And they're going to be making an artifact as well. That's the result of their analysis. Let's move on to the next step. So now we've identified what's wanted in some way. We've identified what components are involved, and it's getting close to time to do the real work of creating code. Let me draw some circles that represent three component teams: component team 1, component team 2, and component team 3, that are the teams of programmers that are going to be involved in implementing their parts for F1. So rhetorical question, can we just give these two artifacts to this component team? Well, maybe if it's very small scale, but in the worlds that I and my friend and colleague Bas Vodde come from, like big telecommunication systems at places like Ericsson, etc., it's much more complex than that, and embedded in these artifacts is a lot of information across many components. And so then there's often a kind of specialist role that's introduced and associated with a component team, and they take these artifacts and they create a kind of little component task artifact for this particular component team as output. And I've seen many names for this role over the years. Technical business analyst is one that I've seen perhaps most often. And you can even tell that there's something a bit funny going on here by the very name technical business analyst. But anyways. By the way, if you ask this component team, what's that? You know what a typical answer will be? They'll say, oh, that's a customer requirement. So they've lost the plot because of this siloing. Moving on. Now, in the next part, I could, in theory, write here that there's code and that the three teams, and I could draw arrowed lines to making the code together. And it would visually give the impression that the code from all of these three component teams is coming together. But I'm not going to draw the picture that way because it visually misrepresents what's going on. Why? Because what's going on in this organization, of course, isn't just F1. It's something like F1 through F50. And as a consequence, there's actually myriad of these artifacts, and many of these artifacts. That's the first point. And what I want to explain here is why showing three arrowed lines from these component teams to code is a misrepresentation with respect to the fact that there's multiple requirements going on. Here's the forces of why that would be a misrepresentative picture. One issue is that there's a lot of component teams with their different component tasks, and there's typically people from different organizations that are providing pressure into the development organization who want their component task for their requirement of interest done first. That leads to a shuffling of priorities, so that, for example, on January 10 at 9 a.m., there's no guarantee that this component team is working on the component task that's the same for the same requirement as this team and the same requirement as this team. They could be working on component tasks for different requirements. And so we have kind of an asynchronous activity with respect to the code being created for different requirements. A second reason why you've got this asynchronous work going on in different components with different component teams is that not all of these component tasks are exactly 17 person hours long. One of them might be 17 person hours, this one might be 100 person hours, and so on and so forth. And as a consequence, the work of the different teams with respect to the code is happening asynchronously. They're not all in lockstep working on the same code for the same requirement all at the same time. Well, what are the implications of that? The implications are that when, for example, if I'm in component team 1 and I make a call to code that's in component 2, that's the responsibility of another team, the handler for that call might not be there. And as a consequence, the code won't actually integrate, it won't link and integrate, and can't actually be done, can't actually execute altogether, because you've got these unintegratable parts, because not all of the code that works together is being created in lockstep. Now, I'm sure many of you have heard of a concept called continuous integration, which comes out of the adaptive Agile community, but I've learned over the years that not everyone knows what continuous integration means. So here's the surprising meaning. Continuous integration actually means to integrate continuously. And the implication of that is continuously, that all the time the developers are integrating all of their code together. But because code here is being done asynchronously, so the different parts aren't actually lining up and can't be linked together, then we can't do continuous integration. We have to do delayed integration until finally at some point in the future, like after a long period of time, like 2 or 3 months, the code is all in place and then we integrate it together. So this, therefore, is a more realistic visualization of the picture, which is that there's delayed integration of the code. Now, moving on, at some point in the future, 2 or 3 months in the future, someone's got to put all of this code on trucks, send it to the factory where it gets all integrated together. Who's going to do that? Which of the component teams is going to be responsible ultimately for integrating all of the code together? And of course, the answer is not clear. So it's very common to introduce another role, which traditionally has been called release manager. And this person will take on a responsibility ultimately to ensure that all of the code is integrated for the release. Moving on, now that the feature is finished, or features are finished, it's time to do end-to-end testing on them. Question, who's going to do the end-to-end testing? Will it be the device driver team? Will it be the middleware team? Of course, it's not clear when you have component teams. And so let's introduce another role. Let's call those people system testers, and they'll do end-to-end testing. Now, moving on, because the activities here of doing the integration of the testing won't go smoothly without problems, there will be problems. That means that there'll be sources of unplanned interruption back into the teams as well, which reduces effectiveness and predictability of processes. Moving on, notice that the work has been chopped up across a lot of different groups. So now we have a coordination problem and a tracking problem related to this complexity. And so we need another role introduced in order to try to coordinate between all of these partial workers in different silos and to track progress. So let's introduce the role of what's usually called project manager or some variation of that. Now, I'd like to step back and look at this analytically for a couple of minutes. First of all, rhetorical question, is this intrinsically necessary? Must it be the case that an organizational design be this way? And the answer is no. There's existence proofs that there are alternative models. But this model is predicated upon the assumption that we start with component teams. And then given that as a constraint, it inevitably gives birth to this kind of complex design with a lot of handoff, a lot of waste, a lot of delays, and so forth. Another point that I want to make is that if you're familiar with the terminology of what are called sequential life cycles, this is a sequential life cycle. And if you didn't know this, if you have component teams, it must beget or give birth to sequential life cycles. Moving on, and I want to connect this back to the previous introduction that I gave on the subject of different optimizing goals like adaptiveness or low cycle time or ideation. Let me ask the question rhetorically, is this a good or a bad organizational design? And I'd like to make a suggestion, which is that we move beyond the false dichotomy of framing things in terms of essentially moralistic terms like good or bad. And we suggest thinking more analytically in terms of the organizational design and simply analyzing what it's consistent with rather than framing things as good or bad. So, for example, let's consider the list of possible optimizing goals that we looked at, which is high adaptiveness, low end-to-end cycle time, or high ideation. First of all, adaptiveness, which means low transaction cost and low switching cost. What do you think? No, I could get into a much more analytical answer, but if you've worked in this world or if you think it through, it's not hard to see that this is very inconsistent with low transaction cost, low switching cost. In other words, this is not consistent with adaptiveness or being able to change direction cheaply, easily, and quickly. How about the second one, low end-to-end cycle time? Now, it's important to add the adjectival phrase here, end-to-end, because we're not talking about the cycle time of one partial team doing partial work. We're talking about, from the customer's perspective, the total cycle time from concept to delivery, from this first of all coming in the door until finally released. And once again, the answer here is clearly no. And we can prove this in multiple ways. If you read, for example, IEEE software engineering, transactions of software engineering, you'll know that the empirical research that shows that these kinds of models are associated with the most schedule overrun of any model. Not surprising. If you have a background in queuing theory and you abstract this to a system with sequential queues in the presence of variability, we know from a queuing theory perspective that this is associated with very long cycle times. Or just empirically, if you actually are paying attention in this world and you start the clock on when this first enters your world until it's finally delivered, you'll see that it's long cycle time, not short. Moving on, how about something like ideation? This is an example that I've introduced on purpose to show cases where it's not so clear. If you look at the research in organizational design of what leads to effective ideation, there's no singular strong pattern, so we can't really say. Maybe, maybe not. If you're familiar with the design thinking movement, however, out of the IDEO company and then out of Stanford University's D School, Design School, the hallmark organizational structure in design thinking, which is for ideation, is a cross-functional team that does everything all together working directly with real customers, and this is very far away from that. So you could make a very weak argument that this is inconsistent with ideation. So what I've tried to do now is analyze this org design, not in moral terms of like good or bad, but more analytically in terms of optimizing goals. Like, is it demonstrably consistent with high adaptiveness, demonstrably consistent with low cycle time, et cetera, et cetera? And the answer is no. And what's interesting is that I've worked with different companies where I visit the management team and they'll have an organizational structure set up like this, and then I'll ask them, so what are you aiming for? What are you set up for? And they'll say things like, well, Craig, we're set up for agility, fast time to market, and working on highest value. When in fact it's easy to see that none of those things are true, and it illustrates a weakness amongst many management teams, which is their inability to carefully analyze organizational designs and consider whether they're consistent or inconsistent with some optimizing goal. I've observed over the decades that's a very common weakness. Well, moving on. Now I want to connect what I'm discussing a little bit to the subject of LeSS, which is an acronym from large-scale Scrum. But also the name LeSS has been chosen to imply the idea that we're not going to suggest scaling here. We're going to suggest the idea of descaling. And if there's only a few takeaways that you take from this brief webinar, one of them is that big idea in LeSS is not scaling, but descaling. Now, what do I mean? If we look at this organizational design and we extrapolate to what would we need to change in order to be, for example, consistent with adaptiveness, which is my specialty, is focusing on org designs for adaptiveness, many of the elements here need to be removed. That's the key point. We don't need to add more stuff in this case. Most of the problems are in the artificial wound of complexity, which has been added in this organizational design. The handoffs, the middlemen, the high work in progress, et cetera, is all a side effect of having this construct starting with component teams. And so the idea in LeSS is to move to a different, simpler model where we descale and remove much of the organizational complexity. As one of multiple examples, we move to an alternative team structure called feature teams. And in a feature team, you have one team that does everything. So this existing organizational design is dissolved, which implies, by the way, that the line manager positions of these existing groups dissolves as well. And we'll come back to that point and the implications of it in a moment. That this group is dissolved and we reform into feature teams where we take people with skills in analysis and architecture and programming and testing and so on and so forth. And this team is not only cross-component, not only cross-functional, and sometimes groups that are introduced to Scrum incorrectly are told that a team in Scrum is cross-functional. Now, the reason I say that's incorrect is that it's not wrong, but it's only half of the story. A team in Scrum is cross-functional, comma, and cross-component, meaning that that one team is what's sometimes called full stack. They can do everything front to back. Now, if you simplify the organizational design, if you descale it to feature teams where each team can independently take on F1 and then from analysis all the way to delivery do everything, the implication of that is the elimination of all of these single function groups, the elimination of all of the handoff and wastes and delays that goes along with that, the elimination of the manager positions of the old existing groups, the elimination of middlemen and project managers and coordinators, because now there's simplicity, so there's no coordination needed. Tracking is trivial because there isn't people doing partial work. And it's possible to show that that kind of an organizational design based upon many feature teams working together on the same product is consistent with adaptiveness, or in other words, low transaction cost and low switching cost. Moving on. There's a dynamic that I've seen in the world of change, which I've been working in for 40 years, sometimes called change theater, or sometimes more derogatorily called fake change. So imagine, for example, that this organization, that this software development group is in this state, and then they go to some Agile training or some Scrum training, and they learn how to scale Agile. And they come back from this course and they reorganize so that now they're a scaling Agile organization. And I want to show you their new organizational structure after having taken a course on scaling Agile, their new radically transformed organization. So first of all, in this deep change, they replace these people with product owners. And instead of them writing big requirements, now they create epics. And in this radical transformation, they now introduce Agile architects, and the Agile architects, they create, let me give a name for these, they create architectural epics. And these people are now called team product owners, and the things that they create are now called stories, and these component teams are now relabeled as Scrum teams. This person here is now called the DevOps group. These are called Agile system testers, and well, we need a new name for these people, and now these people are called Scrum Masters. And now there's been a deep transformation of the organization so that everything is new and different, and now we're Agile. And of course, this is a sad but all too common story of what really happens. And I hope you can see that in this relabeling of the status quo, nothing has really changed, which leads to a question, why does this kind of thing happen? And after about 40 years of working in change and development, I've developed something called Larman's Laws of Organizational Change. And law number one, there's 5 laws. Law number one is the following, that organizations are implicitly optimized to maintain the status quo for low-level and mid-level managers and single specialists. And as a consequence, because there's this implicit optimization to maintain the status quo for these people, and because the real implication of moving to feature teams would be the elimination of existing manager positions, then this Larman's law dynamic takes place. And instead of actually introducing deep change, the organization changes the change, and you'll often hear code words like, well, we need a pragmatic approach to the change. We don't want a religious or a theoretical approach to the change. And this is really code for religious or theoretical means it's not the same as the status quo, and it wouldn't be practical for us project managers to have to give up our existing positions and learn how to program or something like that. So we're going to change the change because it wouldn't be pragmatic for us to change. That's what code words like theoretical, religious, and pragmatic really mean. Well, if you want to learn more about the subject of organizational design, LeSS, and systems optimizing goals, in early March, I'll be giving a 3-day course in Austin on the subject, and also another course on the subject of advanced object design. That's all that I wanted to do by way of a broad introduction to the subject of descaling. And now for our remaining time, I'd like to pass the ball back to Mike to pick up for any comments that he'd like to make, and then to organize any questions that he'd like to share with me. So Mike, I'd like to pitch it over to you.
Yeah, thanks, Craig. At this point, I'd like to have everyone, or encourage everyone, to enter some questions for David while we have him here. We have quite a bit of time to answer questions, so we might as well utilize that. In the meanwhile, what I'm going to do is I'm going to talk about SynerZip and what we do. So SynerZip is at SynerZip, we're here to help our clients accelerate their product roadmap. We can do this at a lower cost because of our model of having India-based software developers. We're also good at, and do this for several clients, something that allows them to change their teams as they go, which is a nice benefit. As you recognize your needs changing in terms of development, testing, or any other kind of skills, we can adapt with that with you in that way. So we have quite a few clients in our repertoire. We're happy to have these clients, and we have a good working relationship with all of them. Next slide. So our upcoming webinar, the next in the series, is going to be with Todd Little. I've had the opportunity to work with Todd in the past. This is going to be about feedback loops and how that's the foundation of business agility. I'm interested in that topic myself. Join us on next month for that, February 18th. So there's a question here about when you have multiple, say, products that have to integrate together. Those on the surface look like components. What's your view on that?
So first of all, to go meta a little bit with the question, the last part was, what's your view on that? I'd like to suggest an idea that I alluded to at the beginning, which is the idea is to move away from personal opinion and move away from the fallacious belief that individual thought leaders or gurus have something insightful to say different than any average person could figure out for themselves. So to take the question, for example, of these little products, if we frame things in terms of the idea of an optimizing goal for an organizational design, then we can move away from the reliance or belief in having to ask opinions of other people, because any one of us is capable of analyzing whether that organizational design element, in this case, myriad little products, is or isn't consistent with something like adaptiveness or low cycle time. So if we have, to take this question a little bit farther, if we've got a bunch of little so-called separate products that have to be integrated together at some point to release something, then if you think this through, I could elaborate, but to make a longer story short, you can probably see that that's inconsistent with really low cycle time if, on the other hand, you contrasted it with having a broader product definition that encompassed all of those prior smaller products. Similarly, with respect to adaptiveness, the transaction cost and switching cost, if there's some kind of a larger initiative of change in the company, which then would cascade into, let's say, the 10 different little products, then getting them all lined up in a new direction in order to move in that new direction as one is going to have a high transaction cost and a higher switching cost than if it was one broader product altogether. So for both of those examples, we can see that many small products are inconsistent with adaptiveness and inconsistent with low cycle time. This is also a good example of a time to bring up the subject of what's called local optimization cognitive bias. Local optimization cognitive bias is this Homo sapien evolutionary bias that we all have, which is basically this focus on the here and now and what I see around me. So for example, you might have just found it surprising when I said a bigger product is more consistent with fast and a little product is less consistent with fast, because by the local optimization cognitive bias, if you're just looking in that little tiny product locally of, let's say, 10 or 30 people, it locally looks like they get stuff fast done. But if you step back to the company as a whole, really viewing things from the external customer perspective, they're concerned with the output of the global system, not of these local little parts. And if you've got many little so-called products, and to deliver something to the external customer, you actually have to integrate many of these little products together, then that's causing an increase from the global perspective, seeing the whole. And therefore, little products is less consistent with low cycle time and high adaptiveness at the global level. And so then bringing this back, and this is a big idea in LeSS, one of the ideas is to move to broader and broader product definitions, where you've got a very big product definition that encompasses hundreds, if not thousands of people within one product, then composed of feature teams. And it's possible to show, as a result, that that's more consistent with adaptiveness and low cycle time. So rather than framing it in terms of good or bad, we can analyze its consistency with respect to some optimizing goal. That's one point I wanted to make. And the second point that I wanted to make is that you don't even have to ask Craig or someone else their opinion on that, because it's relatively analytical for any person to be able to figure this out for themselves. And what we're trying to do is empower people to be able to analyze their own systems rather than relying upon external sources.
Okay, thanks for that. So I think the next question here is, what's the next step? So if you get to this rationalization that you have this type of organization and you want to move forward, what is the next step? Like, what would it look like in the next step?
I'm going to take this also to let's call it a meta level before getting into the weeds a little bit. One of the things that I've learned over my years working in organizational change is the following, and it's something that came to me later in life as well. I didn't really grasp this when I was younger, and that is that people need to own the ideas. They can't rent them. And what I mean by that is a kind of employee engagement in the change ideas, not that they're pushed from outside, not that the employees go acquiescing, okay, yes, we'll go along, but instead solving the problem of the employees, including the senior management, going, we really deeply understand this, and we really want to do this. We own this change idea, and we want to do this. So I've learned over time that the hardest problem in deep change isn't the contents of the change ideas, really all of that secondary, but the deeper, bigger problem is having a group of people that want to volunteer for the change for the deep change through their own insight and owning the idea. So I encourage anyone involved in change to stop focusing on the level of content of the change and instead focus on a deeper level, which is addressing the motivational engagement problem. And if you can solve that problem, then the secondary problems, like what are the details of the change, people will fill that in themselves quite naturally. So the first step is some variation of deep education. And my approach is that I start off working with the most senior level of management. For example, at the BMW self-driving car LeSS adoption, step one, which is my normal requirement for working with a group, is that the senior management, which is usually C-level or C-1, from all of the relevant areas, product management, development, sales, marketing, HR, finance, etc., all of the senior management agree to spend 4 days in a room with giant whiteboards in which they learn how to do what's called systems modeling or causal loop diagramming, in which they can then analyze organizations themselves from first principles. And in that 4-day period, I say very little. Most of what I do is I set up a set of puzzles and I give them the thinking tools of systems thinking, queuing theory, etc., so that they can analyze the consequences of different organizational designs themselves, and then therefore they themselves, through this slow, deep thinking, come to an insight of how the organization should change. And they didn't hear that from me. They were able to figure it out from first principles themselves, with me acting as a coach in essentially the thinking tools rather than the thoughts to have. And I broadly encourage groups to work that way with management, to help them own the idea rather than rent it. And if you start there, you've got a very solid foundation for not change theater, but meaningful change that leads to business results.
Okay, so I'm just abstracting that in my brain for a second. So what you're saying is that it's more about a mindset than an outcome in terms of implementing this LeSS concept.
Well, that step one is, broadly speaking, you could call it a kind of mindset thing, but step one is really education in the deepest sense of the word, and not education where I or someone else tells the senior management the conclusions, but a kind of a Socratic education approach where the senior management aren't told, but are led through Socratic learning exercises where they come to see for themselves what the conclusions of a organizational design consistent with adaptiveness would look like, that they've essentially created that design from first principles, from thinking from themselves. That's a powerful approach to change.
Okay, gotcha. So the next few questions are really people, I'm getting the overall picture that people are trying to figure out what the future looks like. I mean, there's a lot of questions. I'll give you an example. For instance, how do you integrate microservices, which is a common architecture approach, considered or a good practice, whether it's best practice or not, into a feature team approach? Like, how would that look in the real world?
Sure. So there's a generalization here. The questioner is asking about what's the relationship between microservices and an organizational structure of feature teams. But really, microservices is just one specialization of a generalization, which is components, which is when you've got chunks of code that do discrete things. That's the important generalization to see. If you have a chunk of code that does the front-end processing, you have a component. If you've got a chunk of code which calculates a due date, you have a component. If you have a layer or a subsystem or an application or a module or a microservice, you have some kind of a component. That's the important generalization to see. And the answer, therefore, is not coupled to microservices directly. The answer is much more generalizing, which is to decouple the feature teams from the components, whether it's microservices or macro architecture, whether it's a layer, a subsystem, a front end, a microservice, whatever terminology that you want, the idea is to decouple the teams from the architecture so that the feature teams are organized around worshiping our customers and what they want, which are customer features, which can cut across many different architectures, which can cut across a lot of the different code. But we're organized around what our customers want, worshiping them, not worshiping our code. And on the other hand, if we had component teams, because for example, if you had a team that built a particular microservice, that's just an example of a component team. Then you've got teams that are worshiping code instead of worshiping their customers. And more specifically, this analysis that we've just done here is an analysis that would apply to component teams, that would apply to microservices teams. If you have microservices teams, you'll have this very same picture, because any variation of component teams, whether they're microservices or macro services or anything in between, inevitably leads to this kind of complexity. And please don't misunderstand me. I'm not talking about the elimination of components. I'm not talking about the elimination of microservices. I'm not talking about the elimination of a front end. What we're talking about is the decoupling of a team of developers from a particular architectural element, so that you've got full stack teams, and therefore per definition being full stack, aren't coupled to a particular element.
Yeah, that makes sense to me. So what you're saying is don't organize around the microservices, organize around the features, which
exactly.
Can happen.
And the generalization is don't,
databases,
exactly.
whatever.
The generalization is don't organize around components.
Right. So continuing that theme, with large organizations, this can create skill gaps and other kinds of challenges where specialization, the larger you are, the more specialization happens. What's some techniques to combat that? Sure.
I'm going to introduce the answer, first of all, by repeating the point that I made before, that there's what are called Larman's laws, and there's 5 laws. And the 5th law, which I'm now going to introduce and connect to the question about single specialization in large organizations, the 5th law is the following. This is the short form. Culture follows structure. Culture follows structure. Now, the longer form of that, and then I'll explain, is that behavior and mindset, which are 2 examples of culture, behavior and mindset follows organizational design or the organizational system. What do I mean? For example, suppose you have a person who has a specialist job title like business analyst, and they have a career path, BA1, BA2, BA3. Imagine twice a year there's a performance appraisal to see if that BA person can go to the next level, and with which there's more money and, let's say, more social prestige. Now imagine that's the current organizational design. That's a structural element of the organizational design. And then you go to this person, this BA, and in 2 weeks they have their performance review to go to BA level 2 according to the existing HR evaluation criteria. You go to this person and you say to them, Scrum, multi-learning, new skills. So don't worry so much about that BA stuff. Why don't you start learning about programming or automated testing or graphics design, blah, blah, blah. Well, what you're saying to that person is going to kind of fall on deaf ears. They might be willing and interested in some way, but let's be clear, in 2 weeks they've got a performance appraisal according to the existing traditional model to go to BA2. So it's a fantasy. Here's the key point that I want to make. It's a fantasy to expect people to behave in a way which is diametrically opposite what the formal organizational structures and systems are signaling and rewarding. If you've got job titles and career paths, as an example, that are signaling and rewarding signal specialization, then it's a fantasy of human nature to think that people are going to ignore that and, for example, embrace multi-learning. And there's a very important generalization there that many behavior changes need to be preceded by organizational design changes. That's why I often suggest that you can quickly find a very naive and inexperienced change person if they say the following: it's a mindset change. Or if they say, it's a culture change. If you hear somebody say that, here's a tip. It's likely that they're very inexperienced in large-scale organizational design. I mean in a deep way, other than maybe giving a course in some classroom. Because it's very obvious that in large organizations, people are influenced by the organizational system that they find themselves in. And unless you change that system first, you can't expect mindset and behavior change to happen because they're influenced by those things. So to take this back to the business analyst example, therefore, in LeSS adoptions, we need to, as a precondition, introduce a new job category to the company, typically called something like product developer, a very broad, general name which in no way suggests any narrow specialization. And number two, that the career path and salary model for a product developer in organizations adopting LeSS reflects what you want, which is people learning multiple skills and people teaching multiple skills. So for example, at AAA in the United States, which recently was involved in a LeSS adoption, they set up this new career path from product developer 1 through product developer 5. I think it's like typically a 40-year career path. And to go from PD1 to PD2, the person has to demonstrate deep skill in different skills. To go from PD2 to PD3, they have to demonstrate multiple very different skills. So this is a basic HR idea, which is that you have to reward and communicate the behaviors that you want. And therefore, in this case, winding this back to the original question, if you have a large organization with people with siloed single specialist skills, this will be related to the fact that the job titles and career paths reflect that. And until a new career path is introduced with lots of money that rewards multiple skills, you're not actually going to get a behavior that's consistent with that. And that's just a special case of this more general Larman's law number 5, which is that culture follows structure.
Okay, got it. Just looking through the list of questions. There was one question here, and we have about 3 minutes just to set the tone here, about, can you give an example of what a feature would look like for the self-driving car?
Yeah, sure. So for example, in the BMW LeSS adoption, one feature is the car can drive on a highway with no other cars at a constant speed on a straight line without changing velocity or lanes.
Okay, that makes sense.
And that's kind of step one in a self-driving car.
Yeah, of course, yeah. Go straight well. Don't hit anything. I'm just trying to see if there's a lot of kind of duplicate questions. I'm just making sure I've got everything.
Well, Mike, given that we've only got essentially 1 minute left, maybe it's at this time better just to wrap it up.
Yeah, I don't see anything that you could answer quickly, so I agree with you. Craig, I really appreciate you joining us today, and I appreciate the audience joining as well. This is a unique and different way of doing a webinar for us here at SynerZip, and it's pretty exciting. Thanks again, everybody.
All right. Thanks, folks, for joining. Bye-bye.